I'm Cecelia Martinez, and I'm a technical account manager at Cypress, and I'm really excited to be here today to talk to you about network requests with Cypress. I've made these slides for the presentation available at the URL on the screen, and you can connect with me on Twitter at Cecelia Creates. So for those of you who aren't familiar with Cypress, it is a free open source framework that allows you to write and execute tests for any application that runs in a browser. Cypress does execute tests against your application inside a real browser. You can see on the screen here a representation of our graphical user interface when you're running your test locally. So the application under test is on the right-hand side in the app preview. And then on the left-hand side, we have what's called our command log, which, as it sounds like, is a log of all the commands that your test code is executing against your application. This gives us some good information about network requests that are happening inside your application as the tests are progressing. So you can view network requests as they occur in the command log. Here in the screenshot, we can see that after our test code has clicked an element, that a post request occurred. We can see the status code, we can see the endpoint, as well as how we may or may not be interacting with that request via our test code. We can also click on any request in the command log to output it to the console. This gives you some additional helpful information like request headers, response body, which can be useful when you're troubleshooting or debugging failed tests, or trying to better understand what's happening with the network requests from your application. So in addition to viewing network requests within the Cypress test runner, you can also interact with them. So we're going to be talking about two commands today that allow you to work with network requests within your Cypress tests. The first is cy.request, which executes HTTP requests, and the second is cy.intercept, which allows you to interact with network requests. For demonstration purposes today, I'll be using some code from the Cypress Real-World app. The Cypress Real-World app is a great resource. It was developed by our developer experience team. It's a full-stack React application that showcases best practices, use cases, and then essentially all the different things that you can do with Cypress. So it is open source, so if you go to the GitHub link on the screen, you can view the source code as well as a full suite of UI and API tests for the application. It's a Venmo-style payment application, so you're dealing with things like users, transactions, bank accounts, and a lot of very familiar UI components. All right, so we can get started with cy.request. So as I mentioned, cy.request sends an HTTP request from your test code. This is separate from the functionality of your application. It's similar to how you may send an HTTP request from curl or Postman. So the syntax is cy.request. At minimum, you do have to pass through the URL of the endpoint where you're making the request. You can also pass through the method, a specified body, and then additional options for the request. So why would you use cy.request? The most popular use case is actually for API testing. So Cypress, while it's mostly known for UI and end-to-end tests, you can also use the cy.request command along with the same assertion language that you're familiar with in order to validate responses coming back from your server endpoints. So in the example here, this is coming directly from the API test suite in our Cypress Real-World app. We are validating a GET request to our bank accounts endpoint. And the it block for the test is that it gets a list of bank accounts for a user. So in this case, we're using cy.request on line 4 in order to make a GET request to that endpoint. And then we are grabbing the response and we're making assertions against it. So we're expecting that that response status will equal 200, and we're expecting that the response body will contain the user ID in the results. So again, you can leverage the same Cypress syntax that you're used to for API testing alongside your UI test suite. You can also use it to retrieve, create, or update data for testing. So test data management is a really popular topic when it comes to testing, especially when you're doing end-to-end tests. And so if you need to retrieve data from an endpoint, such as a username or password to log in, or if you need to create a transaction or create something in your application in order to test it, rather than doing it programmatically, you can use a cy.request call in order to do that via your API. You can also use it to validate endpoints before proceeding with your test. So if you have maybe like an unreliable endpoint or backend that might be slower or down, or if you're using a third-party service or a microservice and you just want to ensure that everything is all set before proceeding with your test, you can fire off a cy.request, validate that its response status is 200, that it's good to go, and then go ahead and proceed with the test that requires that endpoint. All right, so that was cy.request. Now let's dive into cy.intercept. Cy.intercept is a very powerful, very flexible command. There's lots of things that you can do with it, so we have quite a bit to dive into. But first, let's talk about how it works. So this image is from a presentation called How cy.intercept Works by Gleb Bomtov. And essentially, like you can see in the image here, Cypress routes all HTTP requests through a proxy. So it allows you to essentially literally intercept any request going in and out of the browser from your application in the browser to the internet. So any request can be observed, or what we call spied on, or stubbed. And then it also provides you with a route handler that allows for really dynamic or really controlled matching of which requests you'd like to intercept, which we'll be talking about right now. So first, let's dive into network spying. So you can declare a spy with cy.intercept. You want to do this as early in your test code as possible because you want to declare the spy on the network request before the network request actually happens. So through the cy.intercept command, you can pass a URL, a method, or a route matcher. If no method is passed, then any method type will match. So if you just pass through an endpoint, then Cypress will intercept get request, post request, batch request, whatever it is that takes place to that endpoint. So this is going to be the syntax that we're going to look at. Like I said, you can do a URL, a method, or a route matcher. So let's go ahead and start with just cy.intercept, pass an endpoint. Again, any method type will match to that endpoint. You can also specify the method itself. And you can use a route matcher. So route matcher is an object used to match which HTTP request will be handled. So it's kind of like a mix and match grab bag of different optional properties that you can leverage in order to be really, really granular around which requests that you'd like to intercept. So in our example here, we are leveraging the URL and the query properties in order to say, we only want to intercept requests to this URL that have a query property that matches the expected term. And so that, again, you can see that how you can be very, very specific by leveraging whichever properties that you need that give you the specificity that you're looking for. So once you've declared an intercept, you want to be able to leverage it. And you do that by aliasing it with .as. So it allows you to save the intercepted request to use throughout your test code. So what that looks like is, so in the example that we just talked about, we have cy.intercept, we're passing through our route matcher, and we're saying any network request that matches this route, that matches this criteria, we want to save that and we want to give it a name of search. So now we will have essentially this alias route, this alias request called search that we can leverage throughout our test code. Common use case for that is waiting. So you can wait for a request to occur with cy.wait. So after you declare the intercept and after you've given an alias, then you can use cy.wait to wait for that request to occur anywhere in your test code. So in this example here, we have cy.intercept. We're saying any GET request to our user's endpoint, please intercept that and save it as GET users. Then anywhere in our test code, we can trigger something, click on some elements, have a grand old time, and then we can wait and say cy.wait at GET users. And that's going to wait for that request to occur for real from our application before proceeding with the test code. All right, so the examples that we talked about so far are essentially static matching, right? So it's criteria that you've established in advance when you're defining that route. You can also do dynamic matching. So this is really useful specifically for aliasing GraphQL requests. So the cy.intercept command has some additional methods that are made available via the API. So rec, by passing that rec option through to cy.intercept, it gives us access to those API commands. One of them is rec.alias. So rec.alias kind of replaces .as to allow you to alias a route only if it matches the criteria that you're programmatically defining. So let's take a look at what I mean. In our example, we're saying cy.intercept, please intercept any post request to our API GraphQL endpoint. If you're familiar with GraphQL, you typically have a single endpoint with that handles lots of different types of queries and mutations. So in this case, we're going to pass through that rec property in order to access some API options so that we can do a little bit of programmatic interception here. So we're going to go ahead and grab the body of any of those requests. We're going to define that, and we're going to say if the body has a query property and that query property includes list bank account, then and only then do we want to go ahead and alias that request as GraphQL list bank account query. So this allows us to, again, dynamically grab a request, say, hey, does this request actually have what we need? Yes? Okay, great. Now I'm going to go ahead and name that. And again, that's happening at the time of request because that's what essentially we're grabbing a request that's taking place. We're parsing through the body, seeing if it matches what we need to match, and then we're going to go ahead and alias that. So again, really, really useful for GraphQL requests specifically. So once you've defined your intercept, you've given it a name, you've waited for it, one of the most common use cases is then you can also make assertions about it, right? So you can do that the same kind of similar way that we did for our API request. So in this example, we're going to go ahead and still use our get users endpoint that interception that we've declared. We're going to go ahead and wait for it, and then we're going to do some assertions on it. So we can either use chain style, where we're saying its request.url should include users. This can be, there's certain things that are available for it, like request.body, request.status, that you can just chain directly off of. Or you can use a .then and then grab the interception in order to access any of the lower level interception properties. So that would be the request, the response, the headers, status, everything that you could possibly need. And then you can use that same expect assertion syntax to make sure that the request that went out or the response that came back was actually what it should have been to validate the behavior of your application. And then last but not least, you can also wait for multiple requests. So for example, if we are you still using our get users route, maybe the first time it goes through, it should include user 1, but then we have some additional test code where we're creating another user, and then the second time it goes through, it should include user 2. So we're using the same alias, but we're waiting for the request to occur multiple times because it could be different each time. All right, so that was network requests. Again, we talked about intercepting, aliasing, waiting, and then making assertions on requests going to and from your application. Now let's talk about network stubbing. So network stubbing allows you to essentially bypass the real response of your network and say, give it something else instead. It allows you to essentially trick the UI or the front end of your application. So you can pass the response body to cy.intercept to stub the actual network response. There's a lot of different options for this. I'm going to go through some of the more popular ones. The first is you can leverage a Cypress fixture file. So Cypress allows you to essentially have static assets that you can pass through in your test code. So in this example here, we're saying cy.intercept anything that's going to our /users.json endpoint. Go ahead and stub that out using the users.json fixture that we have alongside our test code. You can also stub the response with a JSON body, just one that you've written yourself that should match whatever the expected response is from the server. And then you can also essentially create a body that leverages certain properties. So if you wanted to define a status code, body, headers, you can do that with an object as well. Those are all static responses. Just like how we could dynamically match routes, we can also dynamically stub. So we have, just like we had rec.alias, we have rec.reply, which is another method or function that can be used to send a stubbed response for an intercepted request. You can pass a string, an object, or a static response. A static response is it's like an object type that gives you some additional options if you want to do things like forcing network errors or delaying or throttling the response. But in most cases, it's essentially for everything else. If a string or an object doesn't make sense, or if you want some additional options. So in our example here, again, we're intercepting to the billing endpoint. We're going to pass through rec, so we have access to those API methods. And then we're going to dynamically get a billing plan name at request time. So again, this is something that we can do dynamically, like as we're intercepting that request, we then are grabbing the data, and then we're going to reply with that data and sub that response. So this can be, as you can see, there's a lot of different a lot of flexibility here. But if for some reason you just aren't able to define that information in advance, or if you need to grab something from your UI, or if you need to validate data before you sub the response out, you can do that dynamically using the rec.reply function. So again, the object will automatically be JSON stringified and sent as the response instead of the real server response for that request. You can also handle multiple requests. Same way you can wait for multiple requests, you can handle multiple requests and stub them out differently. So as of version 7.0, we have this option, and then the request handlers supplied to cy.intercept will be matched starting with the most recently defined interceptor. So this allows users to override the previous stub by calling it again. So in our example here, we declared an intercept to our login endpoint. We're stubbing it out with username 1, and we're saving that as login. Let's go ahead, then we'll have some test code here, and then we're going to wait for that login request to occur, and it should have username 1 because that's our stubbed response. Then we're declaring the intercept again, this time passing username 2. This is going to override that first intercept. We're saving it as login again. We're using the same alias. And then this time, after we've done some test code to trigger that response, we're going to go ahead and wait for it again. And this time it's going to have username 2 because that second cy.intercept has overridden the first one. So we're able to stub responses multiple different ways throughout our test code, depending on what we need. Very cool stuff. All right, so we talked about network stubbing. Let's talk about pros and cons of it. Like, when would you want to do it? When wouldn't you want to do network stubbing? So the first approach is leveraging your real server responses. So this is, a true end-to-end test. This is not leveraging network stubbing at all, letting all of the real API, all the real server responses come back and going through your tests that way. It does guarantee that the contract between your client and your server, or your front end and your back end, is working correctly. So some of the pros, right? It's more likely to work in production. So your test is going to better mimic your actual production environment, and then, provide better assurance that your tests are going to work the same way that your application is going to work, and that you have more confidence that the user is going to have the experience that they expect. You do get test coverage around server endpoints, and it's great for traditional server-side HTML rendering. It gets really hard to stub out a lot of HTML if you aren't using real server responses. There are some cons, right? So it requires seeding data. If you're using a real backend, you're going to need real data. It's definitely going to be much slower because you're completing real network requests. You have to wait for the API to respond. It's also harder to test edge cases because you have to force those edge cases via the UI. You have to force those edge cases to occur via the application rather than creating them via stub responses. So the suggested use is to use it sparingly. It's great for the critical paths of your application when you really need that true end-to-end coverage. The next approach is to stub your responses. This essentially enables you to control every aspect of the response. As we saw with cy.intercept, you can stub any which way that you like. And it's a great way to control the data that is returned to the front end of your application. Pros, you get that control. You can force some certain response behavior, like network delays. You don't have to worry about code changes to your server. So you can even also start testing the front end of your application before the server or the backend is completed. And it's also much faster. But obviously, you're not going to have guarantees that your stub data matches the actual data. You're not going to have test coverage on some server endpoints. And it's also not as useful for a traditional server-side HTML rendering, right? So the suggestion here is to mix and match. Have one true end-to-end test for those critical paths, and then everything else, stub it out. Give yourself a much faster test suite. Give yourself that control that you need. All right, this has been Network Requests with Cypress. Again, I'm Cecelia Martinez. Thank you so much for your time, and I hope this is helpful for you.